All right, we're going to do the last part of our lesson. So we did parallelograms, we did triangles, and now we're going to do trapezoids. If you don't know about these two, please go back and either watch my videos or watch somebody else's videos so you have an idea, because trapezoids depend on triangles and triangles depend on parallelograms. So they're all connected to each other. Okay, let's jump in. Here are 3 different styles of trapezoids that you might see. It doesn't matter what style they are. All of this applies to everyone. Okay, what makes a trapezoid is that they have one pair of opposite sides parallel. So in this case, the yellow opposite are parallel to each other. The other sides are not parallel. Okay, if they are parallel, it's not trapezoid, it's a parallelogram. All right, so here's a trapezoid. This is also a trapezoid. It just happens to have one right angle, and that's okay because we just have one set of opposite sides parallel. The other 2 are not. And again, this one, it kind of looks like a volcano. All right, now if we look at this shape, we want to think of, is there a way for us to split the shape into a shape we already have a formula for, or something that's familiar? And in this case, we can. Okay, if you see here this red dashed line, we've gone from opposite diagonal to opposite diagonal here, or corner, sorry, and made a diagonal. And we've split this trapezoid into 2 triangles. Now these triangles are not the same. They both have the same height here, but they're not the same shape. They have different bases, right? The yellow lines are different, but they're triangles. Okay, let's look at this one. This one, if we go from opposite corners here and draw a diagonal line, we split it into a right triangle and then an obtuse triangle. And this one here, if we go from opposite corners and split it, we would have a bigger triangle here and a little skinny obtuse triangle there. Okay, in all 3 instances, we've divided it into 2 triangles, not equal triangles, but 2. Okay, so this works for every trapezoid. It is actually made up of 2 triangles, every single one. Each triangle has a different base, as we noted above, different bases, okay, not the same length, definitely not the same length here, but the same height. Okay, the height goes from top to bottom, and this triangle here, there's the height. This one, we can actually drop a height this way, even though that's not part of the triangle, and get a height for that triangle, okay, because we're using that as a base. If you don't fully understand that bit, don't worry. You don't need it for the formula. You just kind of got to trust me that I know what I'm doing, okay? I do have a PhD in math, just in case you're not sure if you could trust me. Okay, so we can drop a height this way. Here we've got a height is this straight line, and the height for this triangle up here is this dashed line, but they're both the same. And the same thing here. We could have, which I forgot to do, was drop a height there, and it would go across, and that would be the height of the second triangle. Okay, now this is really important for how we get the formula. Okay, so now that we know we have 2 triangles in each trapezoid, let's go ahead and use that information to get our formula. So we have a base for this one and a base for this one. In math, when we have 2 things that are the same but different and we just want to count them, we use something called a subscript. So base 1, we want to call it B because that's the letter we use for base, and it's the first base. So we put a subscript down here, a small 1 down in the corner, bottom right. That means B1. Over here we have base 2, and we're going to use B again for base, but it's not the same as here. We're going to put a number 2. All right, this does not mean any kind of mathematical operation. It's just a way that we annotate counting in math. Okay, so our first triangle with B1, our formula is 1/2 times the base, our base is B1, times the height, which is H. Okay, our second triangle, we're going to add them together, right, to get the area of the whole shape, is 1/2 times the base, which in this case is B2, times the height, which is also H. Okay, now something you may have not learned yet is that in math, when we have 2 terms like this, if they have any common terms, we can actually pull them out and multiply. It makes our equation easier to work with. So if you haven't learned it, it's okay. Again, just trust me for a minute. Okay, what we have in common here is 1/2. So we're going to use this 1/2. We're going to bring it down here. I'm going to cross it off. Now, what else do they have in common? Well, B1 and B2 are not the same, but H and H are the same. So we're going to write H here. And then once we do that, what's left? B1 plus B2. Okay, now this is the formula that you're going to see in your textbook, or it might look like this, with the H on the end. And that they did that because they want it to look like the area of a triangle. 1/2 base In this case, it's 2 bases added times the height. Okay, so this is commonly given as the formula. I prefer to use this notation, but both are the same. They give the same answer. Okay, so let's go ahead and use it. All right, I always write my formula that I'm using because the formula is literally right here above where I would write it. I'm going to go ahead and just go with it, okay? So we have, and I'm going to rewrite it because I want to use that one. H B1 plus B2. Never mind. I need H. I need B1, B2, so let's label them. This top base here, B1. Bottom base here, B2. Height, H. Okay, let's substitute. This equals 1/2. When I substitute, I'm going to use my parentheses, 4. And now I have B1 plus B2. So B1 is 6 plus 8. Okay, in order of operation, PEMDAS, whatever acronym you learned, we always solve inside of parentheses before we start to multiply. So we need to do 6 plus 8 first. 6 plus 8 is 14. So let's go ahead and rewrite. I didn't do that very well, did I? 4 times 14. Okay, when I have this 1/2 fraction, I like to get rid of it. I don't like to divide by 2 and multiply fractions if I don't have to. So because I can multiply in any order, multiplication is commutative, which means any order of multiplication will do. Okay, I can find an even number to multiply by and divide by 2. Both of these are even, does not matter. I'm just going to do the first one, okay? So we're going to take this 4 and multiply it by 1/2, which is the same as dividing by 2. 4 divided by 2 is 2. Okay, what's left is 1 times, but I don't need to write the 1, 2 times 14. Okay, which is 28. My units are decimeters, and its area, so it's squared. Okay, so the area of this trapezoid is 28 decimeters squared. Let's go down here. I'm going to write my formula. Height times B1 plus B2. Let's label. B1, top of my trapezoid. B2, bottom of my trapezoid. Height is the altitude. Let's go ahead and substitute. 1/2. My height is 20. B1, which is 9, plus B2, which is 17. Okay, again, order of operations, I need to do this inside the parentheses first. 9 plus 17 is 26. So let's do 1/2 times 20 times 26. Okay, to get rid of this fraction, I'm going to look, are either of them even? Yeah, they're both even, so it doesn't matter which one. I'm just going to go with the first one. So 20 times 1/2, or 20 divided by 2, however you want to think about it, is 10. Okay, so if I rewrite this, I end up with 10 times 26. Oh, I love multiplying by powers of 10. It's so easy because we can just add a 0. Okay, that would be 260. And our units are inches and squared because we have area. So the area of this trapezoid is 260 inches squared.